Hello, geometry students, and welcome to lesson 4.2 on isosceles and equilateral triangles. So these are two special types of triangles. You might have some prior knowledge of these that have some good properties that we want to use going forward. So let's take a look at these two types of triangles. All right, so first we're going to look at an isosceles triangle. So it says, how are the base angles of an isosceles triangle related? So when you have an isosceles triangle, what that means is you're going to have two congruent sides. Okay, so I'm going to draw a triangle here with two congruent sides. Let's see how I do. We'll draw this side down here, this side down there, right? I don't want to make all three congruent, just two. There we go. And let's, and let's call this A, let's call this vertex B, and that vertex C. So let's say that segment A, B, and BC are congruent. So AB is congruent to BC. That's my pair of congruent sides. The side not marked congruent is called the base. So this bottom side here is the base. And we want to know if these base angles, angle A and angle C, how they relate. Okay, so that's the question. All right, so we're going to do a little bit of a construction here to kind of prove this using some transformations from the last topic. So number one, I want to draw segment BD bisecting angle ABC. So I'm going to draw this segment. I'm going to use dotted B down to D, and it bisects this angle, so those two angles are congruent, right? That's what bisecting means. Okay. And now number two, I'm going to use that segment as a line of reflection, and I'm going to reflect across line BD, point A. And I believe that because these angles are congruent and these sides are congruent, when I reflect A across BD, it's going to land over here on top of C. That's A prime. Same point. So it folds on top of it. I think the same thing's going to happen with B and D, right? So if I take line BD and I reflect point B across it, I'll also get B. It's the exact same point. It's itself. And if I take a line BD and I reflect D across it, well, D is also on that line, so it's going to be itself, D. So triangle ABD, this triangle, when I reflect it across segment or line BD, it lands on triangle CBD, right? So the reflection across line BD of triangle ABD is exactly triangle BCD. I'm sorry. The reflection of triangle BAD, I apologize, got to name it correctly, BAD will correspond with BCD. So what that means is, this is a rigid motion. Rigid motion preserves length and angle measure, so that means that angle BAD, I said it but didn't spell it. Angle BAD is congruent to angle BCD. BAD, this angle, is congruent to BCD. And what that implies is that your base angles are congruent. So in any isosceles triangle, it has two congruent sides. It has two congruent base angles. Okay, so the next two slides talk about this theorem. So it's called the isosceles triangle theorem. Okay, so it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So notice here it says in the converse. The next slide is the converse. So this is a conditional if P then Q. Two sides congruent, angles opposite congruent, right? So if AB is congruent to BC, that means this is an isosceles triangle. Therefore, let me move this so you can see. Therefore, the base angles ACB and BAC will be congruent, right? Again, this is the base because these two sides are the congruent sides, 4 and 4. And again, these are the base angles. Base angles are congruent. All right, let me open up Desmos, or not Desmos, Savvis here, and we'll show you the interactive piece. Okay, so let's take a look here. So I believe that I'll be able to move some points around. Okay, so here's the theorem. So it says drag the points to change the lengths of the sides and use a protractor to confirm the base angles are congruent. So again, right now I can change this to what? They're the same, right? If I take this protractor and measure, so this angle is about 55, right? If I go this way. If I take the protractor and measure, again, count 10, 20, 30, 40, 50, 55, 56, right? So they're congruent, okay? They are congruent. Now, the converse is also true, right? So this is the conditional. What about the converse? Okay, well, here's the converse. It looks very similar, so just be careful, but this is the converse. So now it says if two angles of a triangle are congruent. If two angles are congruent, then the sides opposite are congruent. So again, this is if Q, then P, right, from before. That's a Q, sorry. So here, I'm being told that ACB and BAC are congruent. These are the base angles. So I'm being told that the base angles are congruent. Therefore, you have a pair of congruent sides, AB and BC. And this would make it an isosceles triangle. All right, so now let me go to the interactive page here, and let's talk about the isosceles triangle. So on the right-hand side here, here's your congruent angles. Again, I can change what can I change? I can change that, okay? So let me change this to, sure, 67, 67. And now if I take the ruler and I measure A to B, right? 7.5, between 7.5 and 8. And then if I bring it over here to C, same thing. Here's 7.5, a little bit between 7.5 and 8. So they're congruent. All right. Notice the base down here, this bottom side, is not congruent. It's only 5 or 6. Okay, so be aware of that. Okay. So there's those two theorems. All right, so let's do 2 more problems here. Okay, so example 2 says use the isosceles triangle theorem. It says an architect is designing a community park between North 1st Street and South 1st Street. The pathways on either side of the pool will be equal in length and will provide effective access and circulation around the pool. To protect the landscape and minimize erosion, the architect will place a triangular section of the triangular cobblestone at the corners along the park plaza. What angle measure should the architect specify for the corners of her design? Okay, so if we take a look here, right, this is already a 50-degree angle. So the question is, what should these two angles be down here at E and F? Well, I believe it says that the North 1st Street and South 1st Street will have equal length, right? Equal length on either side of the pool. So what it's saying is that North 1st Street and South 1st Street are congruent. Notice the markings. So North 1st Street, so North 1st Street is congruent to South 1st Street, which means that this is an isosceles triangle. And by the isosceles triangle theorem, we know that angle E will be congruent to angle F. So we could call this X and X because they are congruent. And now we can use the triangle angle sum theorem and the fact that the 3 angles add up to 180. So let me move this out of the way. Oh, sorry. So we do X plus 50. That should equal 180. X and X is 2X plus 50 equals 180. We'll subtract 50 from both sides. 2X equals 130, and we'll divide by 2. And I get an X value of 65. So those angles at E and F should be 65-degree angles. Okay, next one here. All right, so it says, what are the lengths of all three sides of this triangle? Okay, so in this picture, you see that angles P and Q are congruent. So that means that this triangle has two congruent angles. These are the base angles. So in this picture, the base angles are congruent. So this 6x minus 12, that's the base, which means that it's the other two sides, PR, that must be congruent to QR. PR and QR. Those two sides are congruent. So we set them equal to each other. X plus 20 equals 8x over 3. Okay. So there's a couple things we can do to solve this. If you want to get rid of this fraction real quick, let's just multiply everything by 3, right? So this is a technique. Again, you have to combine these x's, which would take like terms. Let's multiply everything by 3. Notice I multiply everything by 3 because it's distributive. So 3x plus 60. And over here, when you multiply by 3's, the 3's actually cancel and 8x comes down. And now we can just solve this, right? Combine your x's. Let's move the 3x to the right by subtracting 3x on both sides. Let me scoot that over so you're not confused. Right, this is underneath the 8x by subtracting 3x. So 60 comes down, 8x minus 3x is 5x, and then we divide by 5. And you get an x value of 12, right? So that is the x value that we use for all three of these sides. And now we just plug it in to get the length of all three sides. So let's do PQ, right? Alphabetic order. That's 6 times 12 minus 12. So PQ is 72 minus 12 is 60. QR is 8 times 12 divided by 3. That's 96 divided by 3, which is 32. And RP is 12 plus 20, x plus 20, and that's also 32. And you can see that your two sides that are congruent are the same length, 32, and then that base is 60. All right, so I'm going to stop the video here, and we got another one coming up next. All right, stay tuned.